Hello everyone, and today I'm going to teach you about piecewise functions. Piecewise functions. So a piecewise function is a function that is sort of cut up into different pieces. Haha, that's why it's called a piecewise function. Here's an example of a piecewise function, and you'll see some notation here. F of x we're still defining as some expression, but the difference is that it changes depending on where you are. So this particular example, when x is less than or equal to -1, my function is defined to be 2x minus 1. But when x is between -1 and +3, it changes to x squared. And then when x is bigger than or equal to 3, it changes to -x plus 3. So it changes depending on where you are. So the biggest thing you wanted to watch out for if you're evaluating, if you're plugging numbers in, is you have to figure out which of the three are you plugging into. So if I wanted to evaluate f of 10, where would I plug that in? Well, I'm looking for an x value of 10. Well, 10 is not less than -1. It's not between -1 and 3. It is bigger than or equal to +3. So I plug it in to this one. So that would be -10 plus 3, which would give me -7. If I was evaluating f of -2, let me get that out of there for now. If I was evaluating f of -2, where does -2 fall? It's not less than -1. It is between -1 and 3, so I'm plugging it in to this one. So -2 squared, which is +4, and that would be your answer. If I was evaluating f of 0, okay, whoops, I just messed that up, didn't I? Haha. Just making sure you're paying attention. Hopefully you said, hey, Mr. Appel, you just messed up. There you go. If you didn't do that, then you're not watching closely enough, because -2 is clearly not between -1 and 3. It is, in fact, less than or equal to -1. So let's try that again. 2 times -2, we're going to use that one. 2 times -2 minus 1, which is -4 minus 1, which is -5. So that really, I'm going to just pretend like I did that on purpose. That's where you'll make mistakes here. You really have to watch out which of the three intervals, or however many there are, your x falls in. Okay, f of 0. 0 is, in fact, in this interval between -1 and 3. Notice I'm saying interval. These can be written in interval notation as well, so I could have just as easily said -∞ to -1, and then -1 to 3, and then, whoops, close bracket there, because it's equals 3 to infinity. It's, for whatever reason, in piecewise functions, it's usually written this way with inequalities. Honestly, I don't really care. You can write it either way, but you'll typically see them written as inequalities. Okay, so f of 0, 0 is in this interval, so that's going to be this one, x squared, and 0 squared, of course, is 0, and so that would be your answer. One more, f of -8. -8 is in this interval, so that's 2 times -8 is -16, minus 1 is -17. Okay, now let's take a look at what happens if we try to graph that piecewise function. Let's try to graph that piecewise function. So to graph it, I'm just going to make that a little bigger so you can see it. I hope that doesn't get too messy. I need to find some points in each of those regions. So it's going to be 2x minus 1, but only when x values are less than or equal to -1. So you might need to pick a few values in that region. Maybe if x is -3, that's 2 times -3, -6, minus 1 is -7. Let me pick another one in that region, -1. 2 times -1 is -2, minus 1 is -3. So -3, -7, which would be down here, -1, -3, which is here. And that's linear, a linear expression, so it's going in that direction forever. This point right here is included because it's x less than or equal to -1. You've got to focus on those points on the intervals, on the edges of the intervals. So what would happen to x squared if you plugged in -1? So if you plug -1 into x squared, you'd get +1. But our graph isn't defined there, right? Because x has got to be bigger than -1. but it's going to get really close to it. So there's going to be an open circle there. Okay? There's going to be an open circle there. And let's pick a couple other points in this interval. So maybe if x is 0, x squared is 0. If x is 1, x squared is 1. If x is 2, x squared would be 4. So we can plot some points. Hopefully you know what y equals x squared is supposed to look like. It's supposed to be that parabola. We're just only going to see a chunk of it. So that parabola is going to look something like this. How far do I go? Well, I'm going to go right up to 3. 3 squared would give me 9, but it's not quite going to touch 9. It's going to get right up next to it and then stop there. So I'm going to put an open circle there on 9. How did I get 9? That was this boundary. When x was 3, 3 squared was 9, so there's an open circle. Okay, but at x equals 3, this function is defined. It's just defined by this one. So that's negative 3 plus 3, which is actually 0. So I'm going to have a closed circle there. And now you could use what you know about linear to say, well, I have a slope of negative 1, so I'm going down 1 over 1, down 1 over 1, down 1 over 1. And so my graph is going to look like that. You could also pick a few more points, but I'm just trying to give you some options. So that's what that piecewise function would look like. And that's all for now. Thanks.